So we're going to look at the equation of a log function in regards to a real-life situation. We've got welder's masks that have shade numbers between 2 and 14, and those shade numbers dictate what percentage of light actually gets from outside into the mask. This is important with welding because welding creates a lot of excess light. If you don't have a high enough shade filter, too much light gets through, you go blind. It's called welder's flash. If you have too strong of a shade, not enough light gets through, and you can't see what you're doing. So the equation that defines what shade number allows how much light through is given by that equation. And we have a shade number of 12 being suggested for that application. What we want to know is what fraction of light gets through. So if we take that, plug in 12 for n, because n is the shade number, we'll need to manipulate this equation a bit. First thing we should do is subtract 1 from both sides. We'll multiply by 3. Divide by 7. Decimals are okay, so that would end up being 4.71. Take the negative, divide by -1. And at this point, we're stuck until we do a transformation of this function into an exponential function. Keep in mind that a log without a base is a common log, so it has a log base 10 that's not written. To convert this into an exponential function, we'd have 10 to the power of -4.71 equals t. We step over to the graphing calculator, type that in, and we get 1.95 times 10 to the -5. Which we would need to convert into regular notation, convert out of scientific notation because it's a negative exponent. We'll shift the decimal left 5 places. And because we're asking for a percent, multiply by 100. I'll just do that up here. So significantly less than 1% of the light actually gets through a shade 12 welder's mask.